Hello, Professor. My name is Maruf Hossain from WCM555 NBBL. In this video, I'll be demonstrating assignment 1, where I analyze and demodulate a push-to-talk walkie-talkie signal using GNU Radio. The objective of this assignment is to take a recorded signal provided for this assignment, process it through a custom GNU flowgraph, and successfully recover the original audio message. Walkie-talkie systems typically operate in the VHF frequency band from 136 to 174 MHz and use narrowband frequency modulation, or NBFM. The signal used in this project is centered around 146 MHz, which falls within this range. I'll start with the file source block. This block loads the file we downloaded for this assignment. The file contains a recorded complex IQ signal sampled at 1.2 megasamples per second, representing RF activity around 146 MHz. The file source is configured to repeat, allowing continuous playback for analysis. The output of the file source is connected to a GUI sync. This block is used to analyze the signal in the frequency domain, which helps identify the location and bandwidth of the walkie-talkie transmission and determine whether frequency translation is required. From this frequency domain analysis, we can determine that the signal of interest is offset from 0 Hz, meaning it is not centered at baseband. To shift the desired signal to baseband, a signal source block is used. The signal source is configured as a cosine waveform with a frequency of -1.051 MHz, a sample rate of 2.4 MHz, and an amplitude of 1. The signal acts as a local oscillator. The output of the signal source is multiplied with the IQ signal using a multiplier block. This multiplication performs frequency mixing, which shifts the desired walkie-talkie channel down to 0 Hz, effectively translating it to baseband. A frequency domain analysis after this stage confirms that the signal is now centered at baseband. Next, the signal is passed through a low-pass filter. The filter parameters are sample rate at 2.4 MHz, cutoff frequency at 12.5 kHz, transition width at 2 kHz, and decimation factor at 50. The cutoff frequency and transition width are chosen to match the bandwidth of a narrowband FM voice channel, which is typical for walkie-talkie communications. This filter removes out-of-band noise and adjacent signals. At the same time, the decimation factor of 50 reduces the sample rate from 2.4 MHz to 48 kHz, which lowers processing requirements and prepares the signal for demodulation. After the filter, the signal is passed through a simple squelch block. The squelch threshold is set to -30 decibels, and the alpha value is 0.1. This block suppresses background noise when no transmission is present. When the signal power falls below the threshold, the output is muted, which significantly reduces static and improves overall audio clarity between transmissions. The cleaned signal is then fed into the NBFM receive block, which performs narrowband FM demodulation. The NBFM receiver is configured with a quadrature rate of 24 kHz, audio rate of 24 kHz, de-emphasis time constant, or TAL, of 75 microseconds, and maximum frequency deviation of 5 kHz. These values are standard for two-way radio communication systems and allow accurate recovery of voice signal from the frequency modulated carrier. The demodulated audio is then sent to an audio sync, which is configured with a 24 kHz sample rate. At this point, the recovered walkie-talkie voice message can be heard clearly. I will now run the flow graph.
Good job. You successfully recovered the audio. Now make sure there is no static or noise in the signal.
As we could hear, the voice transmission is recovered successfully with minimal noise and no noticeable static. The combination of filtering, decimation, and squelch ensures clear and intelligible audio output. This project demonstrates how software-defined radio techniques can be used to analyze and decode real-world walkie-talkie communications using GNU Radio. Thank you and have a nice day.